This video goes over what it means to solve a right-angled triangle, an example of how to solve pairs of right-angled triangles. When you're solving a triangle, it means to find the lengths of all the unknown sides and the measures of all unknown angles. So first thing to do in this case would be to draw a diagram. And you are working with a right-angled triangle, so it should be a right-angled sketch that you draw. And I know that angle C is 90 degrees. And then I've got angle A is up here and B is down here. In the question, I'm told that C is 90. I have that. B is 2.5 meters. Now, little side B is the one that is directly across from angle B. And then the other piece of information that I know is that angle A is 45 degrees. So the sides that I'm looking for are little side C and little side A, and then angle B. The first one that I'm going to find is angle B, because I know that's going to be 180 minus 45 plus 90 from my angle sum of a triangle theorem. So this is going to tell me that angle B has to be 45 degrees. The next thing that I'm going to do is I'm going to find my little side A and my little side C using right-angled trigonometry. So if I make A my chosen angle, the one that I'm given, I have my opposite side here, I have my adjacent side here, and then I have my hypotenuse. So if I wanted to find a little side A first, I need a trig ratio that has the opposite and the adjacent in it. I do have that. I can use my tan ratio to find little side A. So I'm going to start off by writing it out in general and then substituting in what I know. I know that my theta is 45 degrees, my opposite side is A, and my adjacent side is 2.5. Solving for A by multiplying both sides by 2.5. Is going to give me the value for little side A. So 2.5 meters, because tan 45 happens to be 1, so I know what this is now. And then the last thing that I need to find is my little side C. So for little side C, let's do some circling in blue. Now I'm trying to look for a ratio that has my hypotenuse as well as my adjacent side. I do know that too. That is going to be my cosine ratio. So I've got cosine theta is going to be my adjacent side over my hypotenuse, substituting in my angle, which I know, my adjacent side, which I know as well, and leaving C as my unknown variable as my hypotenuse. Remembering that the solving trick here is just to switch C and cos 45. I can rewrite this as C is equal to 2.5 divided by the cos of 45, which is going to give me an answer to 1 decimal place as 3.5 meters. And now I've solved my triangle. I found my angle B, check. I found my little side A, check. And I found my side C. I've now successfully solved the triangle. Let's do another example here. Now I'm looking at triangle PQR, where angle Q is 90, R is 3.2, and Q is 5.3. So again, I'm going to start off by drawing a diagram, putting my right angle there, and my two other pieces. Okay. I know that little side, little r, is 3.2 centimeters. That is the side directly across from angle R. And I know that Q, whoops, that's not Q. Q is going to be right across from angle Q, which is 5.3 centimeters. So what I need to find here is little side P, angle P, and angle R. So let's start off by finding little side P, and I'm going to use the Pythagorean theorem for that, not even trigonometry. So I know that 5.3 squared has to be equal to 3.2 squared plus P squared, and P squared is going to be 5.3 squared minus 3.2 squared. This is going to give me a value for P as 4.2 centimeters. I've now found my value for P. The next thing that I'm going to do is I'm going to find out what angle P is. And I'm going to use blue for that. So first thing I'm going to do is identify my opposite side, my adjacent side, and my hypotenuse. Now when I'm solving triangles, I like to use the information that I'm given in case I've made a mistake in solving for one of the other quantities. So I'm going to use my adjacent side and my hypotenuse along with my cosine ratio to solve for angle P. So writing out my cosine ratio in general, then substituting in the values that I know, is going to allow me to write angle P is equal to the cosine inverse of 3.2 over 5.3. And then that I can do on my calculator and get that angle P is equal to about 53 degrees. The last thing that I have to find is angle R. A couple different ways that you could do this. One is you could use right angle trigonometry, and you would identify your opposite, adjacent, and hypotenuse, and you could use your cos ratio to figure that out. You can also use the idea that all of those angles in a triangle add up to 180, and so you can do 180 minus 53 plus 90 degrees. So 180 minus 53 plus 90 is going to tell you that angle R equals 37 degrees. So there's lots of different ways to find this information. I could have also found side length P using right angled trigonometry once I'd found one of the angles first. There's not really a right way to do it. There is sometimes a more efficient way. That is what it means to solve a triangle. Now let's do an example here. So here I've got two right angled triangles and I am trying to find out what BC is equal to. I know my angle here, I'm given this. So I would have my opposite side, my adjacent side, and my hypotenuse. So chances are I'm going to be able to find side length A and use that and my angle to find side length H. So let's start off and see if I can find that side length A using my right angled triangle. First one. So let's use my blue here. I've got an angle here that I know. My 100 meters is going to be my adjacent side. I'll use a capital letter to label this triangle. This side over here is going to be opposite. I don't know it, doesn't really matter. It's not connected to my second triangle. Now this second triangle here is actually the hypotenuse of my first triangle. And now I could figure that out. I know my adjacent side, I know an angle. I can use that to find the length of my hypotenuse. Here I'm going to use my cosine ratio, starting off by writing it out in general, and then substituting in what I know. So cos 34 is going to be my adjacent over my hypotenuse, which is the adjacent side in my second triangle. Switching the cos 34 in my denominator is going to allow me to solve for the hypotenuse. So I've got 100 divided by cos 34, which gives me a length of about 120.62 what are we at? Meters. Okay, now that's great. So now that's not really what I'm trying to find. I'm trying to find my little h there. So I'm going to switch to red so you can see that I'm now working in my other triangle. And what I know is that A is really equal to 120.62, etc. meters. So now I'm going to use that fact to find my hypotenuse. So I'm going to use my cosine ratio again, but this time I'm going to use it with my second triangle, which is the red one. So substituting in what I know, 43 my adjacent side I'm using because I solved for that from my first triangle over my hypotenuse, which I don't know. Again, same solving mechanism. Really, I'm multiplying both sides by h and then dividing by cos 43. The shortcut is just switching the cos 43 and the denominator. Cos 43. And now I've got that side length is 165. Well, three significant figures. We'll end with 165 meters. So therefore, the length of BC is 165 meters, and there's an example of using right-angled trigonometry on 2